Okay, let's unpack this. So imagine you're an integrator. You've got this massive project, maybe a heritage site or a big corporate campus,
Right.
and you have to get a perfect 4K video signal across, say, 300 feet. You can't run new power, no bulky repeater boxes.
That old copper HDMI cable you have, it's just not going to work. It fails almost immediately.
Exactly. And that's the real world headache we're diving into today.
Hmm.
How do you push these ultra high res signals over marathon distances without, losing anything?
And that headache is precisely why we're looking at tech designed to, well, shatter those limitations. We're focused on the DVIGear DVI-2580 AOC cables.
The Hyperlate series.
That's the one, the HDMI active optical cables. And this isn't just a better cable. It's a whole new approach. It gets rid of signal boosters, external power supplies. It just simplifies the entire chain.
So our goal here is to really understand the engineering behind it. What allows this one cable to do so much work, and why is it becoming so essential for mission-critical jobs?
Well, the performance numbers really tell the story. These AOCs can push a signal up to 100 meters. That's 328 feet.
100 meters.
While keeping that ultra high-res quality. We're talking 4K at 60p with full 4.4.4 8-bit or even 4.2.2 10-bit color.
Wow, okay. That requires some serious speed. They handle up to 18 gigabits per second. But how do you push that much data so far without degradation? You have to be using something other than copper, right?
Absolutely. The secret is a hybrid construction. That's the key. The cable uses 4POF, the polyfluorinated optical fibers.
Okay, optical fibers.
Right, but these are tougher and way more flexible than glass fiber. They handle all the heavy video data. Then you just have 6 small copper wires left over for power and control signals.
So the real work is being done by light. What makes this particular optical tech work in such a tiny, tiny format?
It's all about miniaturization. Inside the connectors, you have these tiny, super efficient engines that convert the electrical signal into pulses of light.
At the source end.
Exactly.
Yeah.
And then it gets converted back to electricity at the display.
Hmm.
The whole process is so efficient that the cable just sips power less than a quarter of a watt directly from the HDMI source.
So no external power brick needed in the field.
None at all.
That, plus the flexibility you mentioned, must make the physical install so much easier than with old, thick copper cables.
Oh, it completely revolutionizes it. The
Ah.
cable's already plenum rated, so it's certified for air handling spaces. And the flexibility is, well, it's just astonishing.
How flexible are we talking?
The minimum bend radius is 2 millimeters.
Wait, hold on. 2 millimeters?
Yeah.
That's almost like folding paper. That's crazy for any kind of fiber.
It is.
Mhm.
It comes from that POF material. And get this, for pulling it through tight conduits, you can actually detach the full-size HDMI connector.
Oh, you can.
Yep. It leaves you with this tiny micro HDMI plug that's only about 12 by 10 millimeters. It makes impossible cable runs. Possible.
Okay, we've got speed, distance, and deployability. But I have to ask about the cost. These hybrid AOCs are more expensive than legacy copper, no doubt. Is the price just for avoiding physical obstacles, or is there a bigger benefit?
That's a great question. And the bigger benefit is all about dependability and security.
How so?
Because the video is traveling over optical fiber, the signal is just inherently immune to environmental noise. RFI, EMI.
Radio and electromagnetic interference.
Right. You could run this cable right next to a massive power conduit and you wouldn't get a single artifact. No crosstalk, no buzzing, nothing.
So that's where sectors like military and medical come in. It's not just about image quality, it's about data security.
Precisely. That optical path has a supremely low RF EMA profile. The risk of data leaking out through electromagnetic emissions is almost zero. Plus, they support all the standards you need, HDCP, Live, EDDA, and they're TAA compliant. They're built for secure operation.
So when you boil it all down, what we've learned is that active optical cables solve that long-distance 4K puzzle. They do it by blending flexible fiber with just enough copper, creating this lightweight, interference-proof design that just bypasses all that old, power-hungry booster gear.
In that very low RFAM profile, it raises a really important question for you to think about. If this technology is silent and secure by its very nature, what other applications are out there? Think beyond just big displays. Maybe secure viewing stations in a nuclear facility, or highly sensitive medical imaging gear where any noise is a problem. What mission-critical systems might rely fundamentally on this one silent feature where data integrity is literally a matter of life and death?